Hello, we are here at Reflex CES in Paris with Florian. Hello, Florian.
Hello, guys.
How are you?
I'm fine. Yeah.
Good. What are you going to tell us about what's behind us here?
So, yes, let me maybe introduce the activity of Reflex CES. A part of Reflex CES today is working on RF technology solution, mostly for electronic warfare and radar application for defense market mostly. So, we have a lot of experience in Reflex on that kind of products. And little by little, on the last few years, the idea is to be at the edge, on the top of the technology every time. So today, these products is what we call the very highest end of technology that we can achieve today in that kind of application.
So if we're trying to understand today's solution, you're saying in order to get the right output, they have to modulate or they have to make the signal flexible because they don't have the hardware that's flexible that
Yes, that's correct.
So I think the important thing is today's technology gives the manufacturer the problem.
Okay.
Is that right?
This is correct.
So what you're saying is they already have a very complicated time. They already are trying to create these radar and aerospace products that already are hugely complicated. And what you're saying is, and then we come along and we create another problem.
Okay.
What if we took away that problem and we made our products a solution to their problem?
So yeah, of course, yes. So what I said, the limitation due to this technology historically make a lot of constraints for the designer of the final products, and specifically to put some very complicated hardware stuff before this kind of application. These new products now, and little by little from the last few years, the idea is to increase the capability of the RF converters, to decrease the needs of hardware stuff before this RF conversion stage. The idea of this kind of products is to make easier the architecture and the design of the final products by using much more versatile products. And this is exactly what the AV153 do today.
Right. Okay. Will that also extend the life of that product in whatever the end application is because it's solving problems early?
Exactly. So the idea, you know, it's on. We see that on other kind of application historically, radio, television, etc. Everything is going to full digital now application. Full digital is very nice because it gives you a lot of flexibility, a lot of possibility to improve the technology without having changed the hardware or anything. This is what we see on the computer, etc. Today, this is also what we see on the radar, on the electronic warfare system. Putting a full digital way to process everything brings a huge amount of opportunity to maintain the products without having to change the hardware every time. Just have to update the software, the configuration inside, and okay, the system can do another mission, another kind of mission, can bring you some upgrade, etc. So it also improves the lifetime of the products due to that, and also the amount of mission it can provide.
Should we have a little look at what you've got there then?
The AV153.
Yes. In today's systems, radar and electronic warfare, where does that sit and what is it doing?
So first, this is a ruggedized product. Okay. It's perfectly suited to go inside very harsh environments, aircraft, boats, tanks, drones, everything that can operate with quite high temperature, quite low temperature, able to manage shock, vibration at a very high constraints. And it's quite integrated, so it can be inserted inside small system, integrated system with quite small weights, small place inside the final system.
Right. And what is its job?
Okay. So this job is to provide the acquisition, so the analog to digital conversion, all the processing, the data processing, and also all the generation, so the digital to analog conversion with the RF performance I just talked about, so very high level RF performance, and with a lot of processing capabilities, because more you have data, more you need some processing capabilities to process it correctly.
Good. I think you covered it. Hello, welcome to Renault.
Hello, Gay. How are you?
I'm very well. We've been talking with Reflex CES about their AV153 product, which could also be called the Agilex 9 Direct RF VPX board. Yes, I read that. So, tell us about what actually happens if I'm a design engineer today and I work in radar, if I work in electronic warfare. I know I'm going through this process of digitalization.
Yes.
I know that world is coming to me and I have to understand it. So what we'd like to see today is see that board in action so they can trust, if they go forward and evaluate that board, what will they see?
Okay.
So let's talk about that.
Yes.
Renaud.
Yes. So here we have a test setup we use at Reflex US. We have a chassis with the AV153, and we have all the equipment, the lab equipment, to do the measurement of the board. Here we have a single use case where we generate a signal from a signal generator. It is connected to the AV153, go to the digitalization part, go back to the generation part, and go to the spectrum analyzer. The use case is quite simple. We do a downsampling by 16.
It's the information coming in and the information coming out.
Yeah,
Excellent.
it's quite easy.
Yep.
And now we are generating 16 gigahertz signal,
Okay.
and we can see it here on the spectrum analyzer.
Okay.
And if we change like the frequency, we will see most of the bandwidth, the instantaneous bandwidth of the board that can be displayed here because the spectrum analyzer is a max hold mode, so it is storing still in the memory the signal.
Right. Yeah. Yeah.
And here we see, in fact, the instantaneous bandwidth in the by 16 downsampling. So 64 gigahertz decimated by 16 is a 4 gigahertz instantaneous bandwidth.
Okay. If you had to summarize the benefits of what you've just discussed, what would you say that they were?
Yeah, probably, you know, if we are speaking about electronic warfare, space is quite high benefit. Because why? Because the ability to process up to 20 gigs has been always there historically. How we do that with previous technology? Just by putting together a lot of different boards, a lot of different converters to do that.
Yeah.
Okay, that board can replace historically up to dozens of different boards together inside only one
Right.
board.
So in my legacy, I've got dozens of boards in a small aircraft, and now I have one.
Yeah, okay. Or you can also see the opposite. On the legacy, maybe we could not achieve that kind of capabilities on one aircraft because the system was
Just
too large, too costly.
But on the flip side, we can give a drone
Exactly.
that bandwidth because it's in such a small space.
Exactly. So that adds now the opportunity to put this technology and this capability on very small systems such as drones now. Also flexibility, of course. Why? Because we talked a little about earlier, but previous technology requires to put some specific hardware stages in front of it to reshape the signal. Okay? Now with this kind of technology, the signal is reshaped digitally. What does it mean? It means that by reconfiguring the application, reconfiguring the FPGA design, we can change the mission, we can update, we can upgrade the system without having to modify anything in terms of hardware. So this is a kind of flexibility benefit now. Okay?
Okay.
And then, of course, the speed. And it's a very important thing as well. The speed, just because we replace a large amount of elements into just one. So it adds some speed, some reactivity in every stages of the processing. It also improves speed in terms of hardware and system development, because having everything inside one board is much more simple to design, to engineer, rather than having 10, 20 boards.
And less opportunity for things to go wrong. Stability and reliability.
We are speaking
one
about
concise box doing the same. If there's 12 things that can go wrong.
Exactly.
There's only one thing.
Exactly. So we are speaking about reliability, less chance to have a failure.
Good. Yeah, I think you covered it.